Well, this is it. This is the last video of 2021. It's December 31st when I did this repair and shot this video. I'll have it uploaded long before the calendar flips here, but some places it's already 2022. So Happy New Year, everybody. This is a Sony TAF700ES. This is a stereo integrated amplifier that was part of Sony's ES lineup, and this one came in and it's got distorted or very low sound on one channel. Right channel is distorted. Couple common problems with this. Some of them do develop bad connections on it. I noticed that this one, he's got it set up to use through an adapter. There's a switch on the back here for the adapter, and sometimes they go bad. Let's pull the top off this one and take a look and see where we're losing the signal. Now, I will say these units have been very good. They haven't had a lot of the problems that a lot of the other Sonys have. The biggest problem on these is switches. You'll see this is a connection cable for a slide switch that's on the back. And there's another one down here at the bottom. The biggest problem on these is switches. That's your input switches and so forth. Go bad. That's the biggest headache with these ones. And there's one switch in particular, which is one that's not used very often. It's actually used to switch between the adapter input and bypass. Right now it's in adapter mode, so I've just plugged in an adapter cable. This would be like where an equalizer would be plugged in. It connects between the preamp and the power amp. And we can usually use this to determine whether we have a preamp or a power amp problem by switching our leads around. As you can hear, even when I switch it to the right channel, I'm still getting sound. So we know that the preamp is working properly, but the power amp is not. Quite often the problem is right here in this switch. So first thing, before I even take this thing apart any further, I'm going to give this switch a shot of cleaner, and we'll operate the switch and see whether the right channel will return. I haven't touched anything yet because I wanted to make sure that I was able to catch the problem on camera, so I haven't done anything. Right now it's sitting in adapter mode. Switching to normal would actually bypass using this, but I don't want to touch anything until I know what direction we're going, and I wanted to capture it on camera, because if it is a switch and I move it and get it to work off camera, I will have missed that Kodak moment. So I've got my contact cleaner. We'll get it into this switch here, give it a shot, and then activate the switch. Whoops. Okay, let's activate the switch. I do believe the right channel just came on. Yeah, it did. Right channel, left channel. Sometimes it's the simplest fixes. A shot of cleaner into a switch that's not used on a regular basis. There you go. Oh, that'll be $149. Thank you very much. Just kidding. But hey, that's what shops would have charged. You know, you took something like this into a shop and it would have been, you know, I'm thinking of one particular shop that is relatively close to where I am, and they would charge a $95 diagnostic charge, and that would be it. But that's crazy, huh? Now, if it's in normal mode, I can actually remove this cord. It's not needed. That's just for an EQ. Okay, when I first plugged it in, I saw what mode the amp was in. Before touching the switch, I figured I better just check it. And there we go. I had very low and distorted sound coming out of that speaker. And now we got right channel, left channel. clean the other switches while I'm at it, and we'll do an inspection for the infamous regulators that decide to break their solder connection after a while. So we will take a look at that and just check them out, and I will give the other switches a shot of cleaner while I've got it here, because they likely will need it. Now, one thing that does affect this amplifier, like all Sony's amplifiers, is ground connections that work their way loose due to expansion, thermal expansion of dissimilar metals. And this ground screw is no different. Check this out. Yeah, that's good ground, all right. That's a real good ground. Let's tighten that one down a bit. Looks like somebody's already tried to torque it in the past. But these things always have a tendency to work their way loose. Ground screws are famously bad on a lot of the Sonys. Fortunately, on this unit, this is the only one that you really have to worry about, because none of the other screws have got they'll have like a metal spade over top of it to ground the screw. None of the other ones are grounding screws, they're just mounting screws, so they are not problematic on the driver boards here or on the amplifier board. Those ones are not so much of an issue. I do want to check the regulators though. So to do that, I'm going to have to pull the bottom off so we can inspect the 3-terminal regulators and the regulator transistors, because they're a known problem area on all of these units. Just from, again, the heating and cooling. Parts that get hot have a tendency for the solder to crack. So, like all good amplifiers, this one has an access hatch, which makes servicing easy. I wish every amplifier had an access hatch. You know, it's one of those things that was started by a company that starts with Yam and ends with Aha. But Yamaha were one of the companies that started the entire, let's not have an access hatch on the bottom of our receiver or amplifier, because nobody needs to ever go in there. Once this thing's made, it's never going to break. It's never going to need any maintenance, and if it does, oh well, too bad, so sad for you. One long screw, the rest of them are relatively short. The unit is unplugged, by the way. Just for those of you who might be worried they're going to stick my fingers in somewhere where they shouldn't go. This one does have some pretty good size filter caps. Let's just see if they have discharged. It's been unplugged for a few minutes now, so our filter caps are, of course, all drained down. So there's no voltage, no hazard. Ooh, 1.7 volts. I'm real scared of that. Oh, look at that. Here we have the infamous yellow glue. You can see what it's doing to the copper trace here. It is actually eating into the copper trace. So we'll clear that off to prevent that from causing further problems down the road. You can actually see it eating into the copper right there. You see? Look at that. That will eventually have eaten all the way through and would have destroyed that connection. So we'll just clear that off. It might actually be a good idea just to apply some solder over top of that, and again on the other side here, because it was also starting to eat into this other trace over here. You see? You can see where that circuit glue had started to eat away at the copper. This stuff was bad stuff, and that's exactly what it does. It hadn't caused a failure on here yet, but it would have. Over time, that would have eaten away right through this complete trace, and then we would have had an open circuit. You can see all the oxidation that's been occurring. So I'm just going to get my soldering iron going, and we'll actually put a bridge over top of here. I'll put a chunk of bare wire right across this section here, just to make sure that doesn't go open, because you can see it right there. It's eating through there pretty good. The bottom side of that glue looks like that I took off the board. And you can see right here, if I can get a closer up shot, I guess that's as close as I can get, but that copper was almost eaten through. This section right here, okay, there is no copper there. That's the actual circuit board material. It's eaten through this whole part, and it only had that little bit to go, and then this would have gone open. And depending on what that feeds into other circuits. That could have caused, that could cause all kinds of nasty things, because if you look at what that's feeding, you know, that's feeding back into the amplifier circuit. Okay, it's providing one of the voltages over here to this channel, and ultimately, if it went open, loss of bias, for example, could, you know, cause that whole channel to blow up. If you lost one of your bias voltages and your other transistors went into full conduction, boom. So it's important to remove this crap when you see it. And any of these amplifiers that get to be this type of vintage, working or not, it's always a good idea to do an inspection and look for stuff like that. This amp actually looks to be in really good shape, except for that. That is a disaster that was just waiting to happen. You can see it. You can see how clear as day that's been eating away, and it wouldn't be much longer before it would go open completely. So the way to fix this, to make sure that it doesn't happen again, is I'm going to take a piece of copper wire, bare copper wire, and we're just going to lay it down over top of the board. And we'll put it right in place of, right over top of this, right from this capacitor. What's going on with my soldering iron? It's like it's not hot enough. According to the temperature gauge, it's hot enough, but it just doesn't seem like it's hot enough. I'll tack it down as well over here, just so that it doesn't move. And then we'll bring the wire along and tack it down right over here at the final point. And this other side over here, it doesn't look like it's damaged too bad. It would have gotten into there as well. You can see where it was eating away at the trace there, but I think that this one we're probably okay. It was just the edge. So this one should be good now. As you can see, I've got a nice solid copper wire that covers that entire trace. And I soldered it down here so that it can't move. I'd say this other side here looks to be okay. But some of the other things I want to check on here is the regulators, for example. How they look. It looks okay. I guess that's actually a diode. That's a dual diode there. The rest of the board actually looks good. I don't see anything on here that it really looks like it needs attention. That board looks good. The only connection there looks like it might be, I don't know, let me just see if it'll move. That looks okay. That's the one grounding screw. The rest of these go into this is like a composite. It's not plastic. It's like a composite base. That one screw grounds it to the main chassis. So the only thing remaining to do is to get some cleaner into those switches, which is going to be fun for one of them anyway, because of where it's located. The other one's relatively simple. And for you guys wondering, this was hanging off the bench. Sticking out, the bench was right to here. So this metal bezel, this nice brushed bezel, was in no time in contact with the wooden bench. That's why I had it pulled forward. Because this unit is in really nice shape. Considering the age of it, it's in excellent shape. Here are the regulators that I was looking into. We'll see whether these need to be reflowed. Regulators tend to give us the most trouble because of the heat. Right, they get warm. It's going to give these ones a close look. But I don't see any problem with them. They look okay. At least from a visual inspection, they all look fine. Now I got to get some cleaner into this switch here, and then there's another one that's below it, which is going to be even more fun to try to reach. But okay, one of the switches, there's an access hole down here that I can get into this one. Bend the end of my little nozzle here. Which one is that? That's this one. That's the tape record selector switch. And then the main switch is up here. I can get into this one from right back here. Oops. There we go. Okay, get into that switch. And then the phono selector switch it's on this board over here. It's right there. So that one's easy to get to that. That's just to select the preamp between moving magnet and moving coil. So this one shouldn't be too hard to get to because it's right there. Okay, I've got the unit plugged in again. Let's fire it up. Right channel. Left channel. There's another switch here too. There's another one back here. This one goes to the tape 1, 2, and 3 input. This one can have 3 taped exits. It's right below the other switch. It's right here. So let me see if I can get my cleaner into this one. There's a hole on the side of this. These all have like a little hole where the cable the cable goes into it. And this amplifier is one of the few that would be welcomed into my system. Like I'm using in my studio, I'm using an SUV9, which is Technic's amp that's equivalent to this. Very good, high power amplifier, big capacitors, lots of power. These were nice amps. This would be one that would be welcomed into my system. One of my systems. I've got too many. I mean, my main listening amp that I have is a vacuum tube amp. Let's listen to that start up again. Oh, it's just all the relays clicking in. It's got relays for the speakers, you see. A plus B, A, and B. So when it fires up, it kind of cycles through the relays. That's what all those clicks were, I heard. Let's check the tone control. Muting. Okay, I would say this one's done. So if you have one that's got distortion or one channel missing and so forth, check that switch on the back that nobody ever turns. Because that switch is one that causes problems, and it did on this one. That was our problem, was that switch. That was the main problem. Why we had one channel was really low and kind of just distorted, was that one switch. And of course our secondary fault was that circuit glue, which would have become a big problem down the road. It wasn't a problem today, but down the road that would have become a major issue when that trace got eaten through. Anyway, thanks for watching. This is the last one of 2021 because it's 3 o'clock in the afternoon on December 31st. So I'm going to edit this one, and that's it for this year. We'll catch you all in the new year. Bye for now.